also. Sorry, it was a little late. So, are you guys in a group? Are you guys in a group? Okay. I think that there were 2 people who were kind of left out. Are you okay? Okay. What about the other person who was kind of left out? You? So I think you should. Does anybody have only 3 people? Okay, you can go there. So you guys are basically in 4, right?
Yeah, today we only have 2.
Today. Well, and there are.
I don't know if they're coming else, but yeah.
Okay. Okay. For today. So, are there any other people who are a group of 3? Are you guys okay? You don't know, right? So you guys don't really know, right? Over there. I think they have. Wait a minute. Put them over here. Because they are only with 2 people, and they may not have any. Okay. Actually, everybody in the rest are.
So cute.
Yeah. Well, actually, I don't want to make people first, so yeah. So could you go over there? Okay, you guys are in 3 for today, and I think we're basically actually, yeah, over here. This is a group. Okay. If they come, then that will be okay. If they come, that will be okay. If they come, yeah, if they come, that will be okay. They could have 5, okay? Okay, like I said, basically we're doing group works, and I want you guys to be in a group of 4 or maybe 5, maybe 5. If there are people who are in 3, yeah, I may think of that later, but for now, 3 or 4 or 5. And so, okay, according to the syllabus, we have to go to the function and applications over here, which is for this week. We are going to learn function from the numerical algebraic and graphical viewpoints. It's very simple. I hope you guys don't, stumble over here, but we're going to go through this only for this week, this section. Now, so when we are, kind of handling some model, and basically we are looking at these kind of data. So there are a lot of ways of plotting data, and this is one type. This will have a table, right? And for example, we have over here a number of Facebook users. over here in the second row. And on the first row, it's about time. So over here, we have 2004. We only have 0 members of Facebook members. In 2005, which is over here written in 1, which is actually 2005, we have 1 million members. In 2006, which is written 2, we have 5.5 million members. 2007, 12 million. 2008, 58 million. 2009, 150 million, and on. So this is one of the way of writing data, written in a table. Or we can write over here algebraically. So N is Facebook members. So in this case, 0 as times 0, which is actually 2004, we have 0 members. So N of 0 is 0. N of 1, which is 2005, is 1 million members. N of 2, 5.5 million. N of 6, 450 million. So so we learned 2 ways of writing a model, a graph, or graphing a data. One is writing in a table, and the other one is writing as a function. And we use n, this n, as a function. So in this case, we write n of t, n parentheses t, for the number of members at time t. And the numbers we have in mind, of course, will be basically real numbers. We're not going to handle, complex numbers, because we are thinking real business, basically. This n, well, it's an image. This over here, we have an image of an n. So in this image, we have t as an input, the year, okay? The time will be the input. And the output for after this n, we have n of t, which is the members. So this is a kind of blackworks, and this function takes the input, the t, and has the output n of t, which is the members. We call this t independent variable, and n will be called dependent variable. And of course, like I said, since we are handling real values, real valuable, these are called real value functions of a real variable. Once again, over here, the table that we have saw is like probably over here, and we call this numerically in a table. Nothing fancy, nothing complex, I hope. Basically, we write these kind of things. Also, some definitions. We call this independent variable. I mean the range of the independent variable. We call it domain. So these numbers are domain of this data. Okay? And on the other hand, we call this the output numbers. We call it sometimes range. Another way of putting the data is, of course, graphing the data. This is one way of graphing the table, the data in the table over here, which is plotted as a graph. So n of 0 will be 0 at time 0. The x-axis will be the year. The y-axis will be the number of the number of members Facebook has. So at time 0, which is actually 2004, we have 0 members. Time 3, T3, we have, what was it? 12. So around over here, we have 12. Okay? Over here. 4, we have about 50, 5, about 150, and 6 at the year 2010, I think, we have 450 members. I mean 450 million members. And actually, we, in a algebraic way, we write it parenthesis x, comma, f of x. Well, I think we should use n, but sorry, we changed it to f. So, for example, over here, we rate this point 4 and f of 4, right? Okay. And we call this kind of stuff graphically plotted. And also, are you guys okay? Yeah, of course, look at the graph. We have to see how the graph works. For example, find some variable over here. What we do is first go to the, if we want to know when, what number of members at the 5th year, we go over here, of course, and then look at the x-axis where it has 5 in it, because we want the number of members at the 5th period over here, and we just go up and see it has 150 members. Nothing, complex. And also, when we say another way of plotting data is also, of course, we have a algebraic way. In some cases, we may be able to use an algebraic formula to calculate the function, and that is why we call it algebraically used. And also, another way of saying is using verbal terms. For example, let n of t be the number of Facebook members in millions. T will be years since the start of 2004. So are we okay with this? It's nothing, complex, right? Okay. Now for a quick example, another example would be like this. The table, of course. The columns, the first column over here is years. And we have data corresponding to that years. So at t at 0, which is actually 2000, we have 24 billion metric tons of CO2. I think this is the world emission of carbon dioxide in year t since 2000. And in the 5th year, we have 28 billion metric tons of CO2, and on. So, the domain of C is, in this case, 0 to 30, and let's just, and if we want to graph it, it will be like this. So this will be, of course, graphing it will be like this. And so we have examples. Now, of course, this is a group work. Are we guys okay? Are we okay with going to the group work? So this will be your first quiz. The total number of iPods sold by Apple up to the end of year X can be approximated by this function. F of x equals 4 times x squared plus 16 times x plus 2 million iPods. Now, we have 3 questions. What is the domain of F? Compute f of 0, f of 2, f of 4, and f of 6. What do these answers tell you about iPod sales? And also, is f of minus 1 defined? The second question, compute f of a, f of minus b, f of a plus h, and f of a plus h. Assuming that the quantities a minus b and a plus h are in the domain of that. And the last one will be just the graph of the shape of the curve suggests that iPod sales were accelerating or decelerating. And you want to go to A. A, okay, you can go A. And who wants to go B? Okay. actually, before that, I forgot to say something. Before that, I want to say about group works. I have this rule for doing group works, and that will be, it's right here. About group works. Point goes to groups that did the quiz right post during the class. So if somebody does it, they all get the point. For the group members, everybody gets the point. But for each group, every person has to raise their hand and answer to some quiz before it goes around that group. So what I mean is that, for example, over here, if you're answering only one, for everybody, every time, then I won't give you points. It has to go around. It has to go for each person before you get another chance of saying answer. Okay? Okay. So I want everybody contributing. This is, of course, because I hate free riders. Okay? And of course, we're recording the person who is answering, and we can, check it. So if you, kind of try to cheat, then we can check you guys out, of course. So before that, yeah. So, do you want to go A?
Yes.
Okay. Wait a minute. Somebody wanted to go B, right?
Yeah.
Okay, B. And wait a minute. I thought that she was, yeah, you want to go C? Okay. Okay, you can, so the people who can go up here and write it on the board. Of course, we're,
Can I get my friend copy?
yeah. For the first place? Oh, okay. Not the blue ones, because the blue ones can't see it. Yeah. Oh yeah, of course. Yeah, right now. And also we're distributing handouts, okay? Some notes that they have formulas that we are learning about. So I think you don't have to take many notes, okay, for that.
Sorry, my bad.
You can also look over here. You can also look over here.
The same thing, right?
And if you see somebody wrong, you can raise your hand and correct it. And that will be, of course, contributing to the class. Yeah. Yeah, that's okay. That's contributing. Well, if you think that is right. Yeah, I think you're okay. Yeah. Yeah, but I think you need a practice.
What does this number tell, right?
Yeah. Oh, so you can calculate it. For example, a plus h will be in the domain, so you can calculate f of a plus h. Yeah, something like that.
You can replace x value with a plus h is equal to
Yes, that's right. Oh, yeah. No. yeah. I think that person and also the person was there. So I think you need to track people. And then after that, I want to record yeah.
I don't have enough space. Can I do it here?
Okay.
Like, because this is the first.
Okay. And what about
What is X? Like the year, right? like over here? Actually, to be precise, you have to use 0, 1, 2, 3. But interpretation, you have to use years. So yeah, you're right about that. This graph should be 0 to yeah. And thank you for pointing that out. Trigonometry or?
You guys are okay. Now,
Where is it?
okay, thank you very much. Of course, please write your names, those who wrote on the boards, okay? Carol will be collecting it. First of all, for about the one that we have over here, what is the domain of F? What is the domain of F? That will be, who did it? Oh yeah. The domain of F will be over here, right? The 0 to 6. You have something to add? No. The 0 to 6, the time will be the domain. The time. One more time before we go on about the domain. Where was it?
the set of values of an independent variable for which a function is defined is called its domain. The set of values of an independent variable. Independent variable was in this case, the t. Okay? So in this case, the year over here will be the domain. And actually, they wrote it, right? The group, what's your name? Yeah. Eric? It was 0 to 6, right? The domain. Yeah, so you guys were right about that. Okay, here. What about compute f of 0, f of 2, f of 4, and f of 6? Yeah, this is rather tedious, I know. But I think they got it right, right? For example, when we calculate f of 0, just put in 0 and just do the calculations. If we want f of 2, put in 2 in the x and calculate the stuff, which is, of course, 50. The same thing over here. What about f of 4? That would be like this. And f of 6. Just put in 4 and calculate this equation, which is 1 is 30. And the f of 6, do it the same thing. We have very tedious equations, stuff, but, just calculate it. Now, so the last one was f of minus 1, right? And actually, this minus 1, well, Eric put it in words, and yeah, theoretically it says can't be negative. It means that is 2002, iPod has not been released to that market, and I think he wants to say that minus 1 is not, valid. Yeah, you're right. And actually, look at the domain. It's minus 1 is out of the domain. So it's just, minus 1 is not in the domain of f. So in this case, f of minus 1 is not defined, actually. And I think Eric wanted to point that out. Yeah, where was it? Where were we? Now for the second one. Yeah, compute f of a, f of minus b, f of a plus h, f of a plus h. And I had a question that the quantities a minus b and a plus h are in the domain of f. What does this mean? It means that, for example, if we are calculating f of a, we need to know that a will be in the domain of over here. So in that case, we can put a into x and calculate it. Or maybe if the a plus h are in the domain of f, then we can put a plus h inside the x, as an x over here, and then calculate it. It has to be in the domain when we are calculating it. Otherwise, we can't have minus 1, right? F of minus 1 for it in this example. So that is what this means, assuming that the quantities a minus b and a plus h are in the domain of f. Now, we have the solution is over here. For example, f of a is just putting a and substituting x as a and calculating it. Well, it's actually just writing x into a's. About b, minus b, f of minus b will be putting minus b in the x and then do the calculations. In this case, minus b, the raised to the power 2 will be b raised to the power 2. 16 times minus b will be minus 16b, like that. And a plus h, the f of a plus h will be the same thing, but you have to factor it out, simplify it. The last one we have over here, f of a plus h, is just calculating f of a
which is written over here, and adding h afterwards. So yeah, I think you guys are all right. Okay. Yeah. And the last one. Okay. Over here. Looking at over here, actually putting calculating the f of 0, f of 2, f of 4, f of 6, which is actually calculated over here. We just can put it in a table, or we can put it in a graph. Actually, the group over there, first calculate it, and then plot it at over here, here, and here, and here. And then kind of assume that it will be in a line. To be precise, this has to be 0 to 6. So actually, the group wrote this graph, actually interpreted it as in years, but actually this has to be 0, 1, 2, 3, 4, 5, 6. And yes, the sales is accelerating because it's going up. So, are we okay with this? Do we have any questions? Another one is the vertical line test, which is actually a very theoretical concept. When we are dealing with functions, we have to be aware that it is a function. So what I mean is that because f assigns a single value f of x to each value of x in the domain, it follows that there should be only one y corresponding to any such value of x in the graph of f. That will be y is just f of x, or maybe f of x is just y. In other words, the graph of a function cannot contain two or more points with the same x coordinates. That is, two or more points on the same vertical line. What I'm saying is that in this example, we have f of x, right? But we can't have two points at, for example, over here, because it's already over here. So the vertical line text is actually saying that we can only have one value for each point at the domain. We can't have 2 points. And yeah, and actually putting in a graph, we can see like this. We shouldn't have any more than one, at most 1 point. And put in more words, for a graph to be the graph of a function, every vertical line must intersect the graph in at most 1 point. Not 2, not 3, at most 1 point. In this case, we can't have 2 points. So what we do is draw a graph, and then afterwards, what we put a line vertically and see if this test is valid. For this example, if we put a vertical line over here, then we can see that there are 2 points that intersect. So the vertical line test suggests that it has to intersect at most 1 point. So in this case, the vertical line test is not valid. For example, over here, the next one, if we plot a vertical line over here, or maybe other places, actually it only has intersection at most 1 point. So this one is actually a function. The last example over here, we can draw, we have a graph, but if we draw a vertical line over here, then we have 3 points that intersect that vertical line. So in this case, the last one
is of course not, doesn't go through the vertical line test. It's not valid, so it's not a function. Yeah, and there are some examples of functions. One of the most famous one, and also we're dealing with the next section and the third section, will be the linear case. We write it f of x equals m times x plus b. Graphically written, we write it like this, or maybe we can write it like this. It depends on the slope of the line. We're going to learn that later. Actually, the m, which is a constant, is a slope, and the b is an intercept. For example, over here, it intersects the y-axis over here, so we have b as 2. And the slope in this case is actually minus 2. There are other examples. One is a quadratic case. Algebraically written, we have f of x equals a times x raised to the power 2 plus b times x plus c. And if we, for example, if we plot y equals x raised to the power 2, then we have this kind of graph. If you have y equals minus 2 times x raised to the power 2 plus 2x plus 4, we have this kind of graph. For the cubic case, we have generally written, we have f of x equals a times x raised to the power 3 plus b x squared plus c times x plus d. Actually, in examples, we have these kind of graphs. For polynomials, we have this as an equation, and for example, if we have this kind of equation, then we can plot it like this: the x-axis and the y-axis, of course. This is x raised to the power 6 minus 2 times x raised to the power 5 minus 2 times x raised to the power 4 times plus 4 times x raised to the power 2. Well, anyway, we have these kind of very complex functions. We have exponential functions written like this: a times b raised to the power x. Examples would be like this. And rational functions, p of x over q of x. And p and q are polynomials. We have these kind of functions as examples. Now, absolute value will be like this. Or it could be like this. If the numbers, the equation in the absolute value will be 2 times x plus 4. About square root, we have y equals square root of x, or maybe y equals square root of 4 times x minus 2, which is actually, as an example, will be like these. Now, since we have a lot of times, and actually, are we guys aware of the Weber sign? And does everybody already assigned it? Okay. So for this week, I'm going to give you guys a course assignment about this section 1.1. And actually, since the curriculum says that I can do only 1.1 in the first week, we're going to do group works for this one. Okay. I'm going to give you guys about 17 quiz, which will be in the assignments, but we're going to do a little bit here because we have time. So the first one will be like this. Now, we have this. Can we see this? No. Yes, okay, I see you guys.
Yeah. Okay, can we see this? Can everybody see this? Okay. We're going to do group works according to these quiz, which will be assignments, but we are going to do it now, of course, since we have time. Now, what about this one? The first one. Okay, you can come up over here. Actually, they were first. They were first. We have, everybody can go, okay, okay. Wait a minute. Could I erase this? Wait a minute. I'm going to erase this. Wait a minute, please. I want to erase this. Okay. You have two quiz. On the board. Yeah. The first one is, of course, not that difficult, right? You ready for the second one? Wait a minute, wait a minute, wait a minute. Wait a minute. Okay, are you guys okay with this? F of 0 will be 2, and f of 2 will be 1.5. Okay? Are you guys okay? 1.5. So, the second question. Okay, okay, you can go. Wait a minute, you guys already went, right?
Yes.
No,
Only two of us. Like,
No.
ladies first.
No. You guys already went. So, the other guys. Yeah, you can go.
Okay.
Wait a minute. Yeah, you can go. Wait. Only one? Not for the others? Later. How many groups do you have? Okay, so we have 5 groups, right? For now, right? So I need 3 more, right? Okay, are we guys okay with this? F of 2 minus f of minus 2 is minus 2.5. And f of minus 1 times f of minus 2 is 12. Are you guys okay? And minus 2 times f of minus 1 is minus 8. Okay? So I'm going to put it over here. If it's really worth. Now for the second one. Who wants to go this one? Wait a minute. They were first. You guys, they did one? Okay. Okay, you guys can go. Nobody wants to go? You already went, right? So wait a minute. I want every group for the first. Yeah. Participate for the first. This will be this week's assignments, okay? The number will be changed, but basically it will be in the assignment. Well, I think that will be around. I'm going to erase that one. Oh, okay. I'm going to erase it. Yes. I'm not really sure it's. It should be 1.1. No, that's 1.1. Wait a minute. I'm going to check that. Okay, you can just go.
1.1. So 1.1 is June.
Oh, really? I'm going to fix that.
Oh, that's good.
Actually, I'm going to fix that. I'll put it next week. Due next week.
So
Yeah.
the one that we're doing right now is June.
Yes.
Why is this and that different?
This and that different? Is it?
Like taking details.
I think it's same. It's the same. Is it? I'm not, I can't, I don't have, I only have, it is, right? Okay. It's the same, it's the same. Okay, f of 1. Looking at this graph, and putting a as 30 over here, 30, and 2a will be 60, right? Right? Okay. Can you see this? Actually, it has a grid, a gray grid. Can you see it over here and over here? And if we want to calculate f of 1, which they did, it's actually 60 because at 1 it is over here, right? So putting, and a was 30, so 30 times 2 will be 60. So this one was, of course, 60. So I'm going to put it 60 over here. And the second point, which is f of 2, over here, will be, the f of 2 will be here. And I think it will be, it is a third grid above the x-axis, and it will be around 90. The f of 3 will be over here, because it's 0, 1, 2, and 3 in the third grid at going through the right. And it will be over here, f of 3 will be here. So, and actually it's basically the same as f of 2, so we can write 90 that they did. And f of 5 will be 0, 1, 2, 3, 4, 5, 5 over here. And actually the f of 5 will be around here. 2 times a. 2 times a will be, a was 30, so 60. And if we want to calculate f of 3 minus f of 2, then what we do is f of 3 minus f of 2, which they did, which was 90 minus 90, so it will be actually 0. Okay? Are you guys okay? Now for the next question. And I think there are 2 other groups left, right? Okay? So what about this? It's getting difficult. Okay, you guys didn't do it, right? Is this too difficult? Oh, yeah, you can go. Yes, I'm sorry about that. Actually, I didn't announce it, so I have to erase it. Yeah, I'm sorry about that. Yeah.
Extra points, right? We did it.
No, it's too easy. Too easy. I'm going to give you guys extra credit for chapter 3 and chapter 4, actually. Which is not really, it's a little bit difficult, but I think, yeah. Because of the typhoon, I'm sorry that it was a little late for that. Yeah. Can you look at the monitor over here?
That one doesn't have time. Yes. Yes, that one.
For homeworks, I basically announce it. So, yeah. If I didn't announce it, then there will be no homeworks. Wants to do f of 2, f of 4, f of 6, and f of 4 over 6 minus 4. There are others, actually.
You can't go.
You don't want to do it? You don't want to do these one?
Oh, wait.
Thank you very much. So f of minus 6 will be over here, right? Yes. That would be 0.5. So are we okay with this? F of minus 6 will be over here. Yeah, 2. Yeah, so actually this one is 2. Minus 2, I'm sorry. Yeah, you're right. Minus 2. And f of 0. What about f of 0? It's over here. Well, yeah, 2.5. 2.5. Yeah, you're right. 2.5. Actually, 2.5. minus 2, well, let's just see, it's 0. I don't think it's 0. And f of 2 will be over here, right? And actually, when we rate graphs, we put a hollow ones as not in the graph. And we put those filled ones as the graph. So in this case, this one is a graph of the point, of that point. So in this case, f of 2 is actually over here, which is, I think, is 0. f of 4. f of 4 is around over here, right? So it's around 2. And they did it right. And f of 6 minus f of 4 will be around here and here. F of 6 will be here, f of 4 will be like here. So it's actually 0. I mean, f of 6 minus f of 4 will be 0. 0 over 6 minus 4 will be, of course, 0. And I think this one will be corrected, okay?
I don't get why f of minus 6 equals 0. Can you explain that?
Yes, and actually it's minus 2.
Oh.
Zing wrote it 0.5, so I'm going to write 0.5. Are you guys okay? This will be assignment, right? And actually, f of 0 is not 2, actually. They wrote it 2, but it's actually over here. It's a little bit above 2. Okay? What about this one? So you guys want to go? I think you guys were the last group. See whether or not f of x is defined for the given values of x. It is defined. Give its value. Answer is defined, undefined. If it's undefined, then write it undefined.
Sure. What is the meaning of it's lost infinity?
Oh, it means it goes
One to
to,
zero or
yes, all to the way, yeah, positive numbers. All the positive
if
numbers.
it's infinity, this can go both ways.
If it's minus infinity, then you can go both ways, but it has to be minus infinity. In this case, it's 0, right? Yeah. So the first one is 8 minus 64 over 1 over 64, right? That will be 511 over 64. And the second one is undefined because 0, a 1 over 0 squared would be undefined, right? But what about minus the last one? It is defined. And? Let me calculate. Does it? Yeah. Minus?
Minus 530.
50? 50 what?
1, 3.
Oh, 1, 3. Oh, sorry. Are we guys okay? Because we can calculate this, right? Minus 8 squared is, minus 8 squared will be 64. So it's not undefined. 0 will be undefined.
So what is it related with domain 0? Okay.
I see. You're right. Yeah, you're right. You're right. Yeah, it's undefined. I'm sorry about that. Oh, yeah. You're right. Thank you very much for pointing that out. Actually, sorry about that. Sorry for the confusion. Since it's minus 8, it's out of the domain. The domain is over here. So it's out of the domain, so it should be undefined. Yeah. So do we have questions about this? Do we understand this? Okay? Yeah. Thank you. Thank you for the sign. Okay? Now, since everybody went through, everybody has a chance for this one. Wait a minute. I saw that first. You need some decoration, right? Thank you very much. So, in this case, yeah, g of 0 will be calculated like this. Put in 0 in the g of x, x as 0, and actually it will be like 6. If we put minus 1 in the x and then calculate, then we have 14. So I'm going to put 6 over here at 14. And what about G6? GR. GR will be putting R besides X and then calculate. Actually, what we do is use this. Functions. Can't see this. Can't see this. Oops.
the last one we have over here will be g of x plus h. Just putting x plus h and then expand it will be like this. Yeah, I think they're right. 7x plus minus x minus h plus 6. So are we okay with this? Can we see this? This will be the answers. And I think we should go a little more further. Okay, they were first.
Ladies first. You can do it.
But I think you went, right? Oh yeah, you guys were. Oh, okay.
Ladies first.
Okay, yeah, you can do it.
Yes, let's go.
Okay.
Are you gentlemen?
I'm actually they went all around. For the last one, they went all around in the last one. They wrote it. So I'm gonna allow those. Oh, yeah, okay, yeah. Because I think they are contributing, actually. So we have a strategy that everybody in a group will be in the blackboard, right? So that is your strategy. Yeah, you're right. You're absolutely right. So that is one way of contributing in this class. But please don't do the same questions. Okay. So basically, I want everybody contributing, okay? Okay. No. I didn't give the first assignment. This will be the first assignment for the next week. Well, she missed the group works. Yeah, the last one. Okay, are we guys okay with this? A, B, C, and D, and what about E? Yeah, thank you very much. The A will be over here, which is actually putting -1 into x will be -5. Right? Are we okay with this? Putting -1 in this equation and then calculating it will be -5. What about 0? That one, okay. Putting 0 in the x will be -2. What about f of 1? Yeah. Putting 1 in the x and then calculating will be 1. The last one, the last two. F of y is just 3y minus 2 because it's just the substitution of x as y will be 3y minus 2. What about f of a plus b? Actually, it will be 3a plus 3b minus 2.
Are we guys okay with this? The next question. Okay. Okay, you can go. But if you can't answer it, then the right will be. No, no. It's that. Yeah, have fun. Yeah, math is fun. Okay, you can scroll it if you want. Yeah. Okay, it's just a constant. It shouldn't be. It should be careless because we are not over there yet. Thank you very much. Okay, 5 of 1 would be 8, right? 5 of -1 would be, g of -1 would be 6. G of 2 will be just putting the 2 in the calculations. You have 57 over 2. Let me put this in. And the last one, I think. The calculation is rather tedious. I don't really think that you need this well, actually, but let me see. Yeah, thank you very much. It should be a little Yeah. And actually we have this, right? Oh yeah, yeah. Yeah, you're right, you're right. Can't copy it, right? What about the last one? We're gonna have last one. They were first. They were first. They were first. Yes, you can erase. Please erase it.
Oh, he's from? X squared. Just this. That's where does it come from?
Okay, what about H? Hey,
Did we do F? Where? I was born in Thailand.
they do H of 0.
It's going up, yeah.
No. So, H of 0,
Which one is
H of 0.
Where is h of 0? The first one.
Okay. Yeah. 1 over 9 will be H of 0. And H of minus 8, this one, right, is actually 1. What about H of minus 10? Minus 10 is right over here.
Yeah.
And then H of x, x raised to the power of 2, x squared will be 1 over who did x raised to the power of 2? Oh, that one? Okay, okay. Yeah, sorry. Plus 9. And what about x raised to the power of 2 plus 1 will be written over here, which is 1. Yeah. It's due next week.
Yeah, but right now we can't access it because it was due today.
I think that should be erased.
Are you gonna like?
No, change it. We're going to change that one.
Can we do how much more?
Yes, you're right. Yes, I'll fix it today. Did somebody do x squared plus 1? H of x squared plus 1? Did somebody do this one?
X squared right the right. Just by here.
This one? This? But it's not valid. What is this? I can't understand this. Yeah, but you should calculate H. I want to calculate H, right? We want to calculate H. So this shouldn't be over here. Yeah. So what is this?
X squared plus 10.
X squared plus 10. X squared plus 10. mean like this? Okay. What? 1 over x squared plus 10, right? Okay. You mean like this? Okay, we're going to see how it goes. And actually, so that's for testing, and we can see if it's okay. Okay. Stop. And yes, basically we have our right. Actually, the one we had the graph. Okay, over here this was not right. Okay, so please be careful with that. Over here and here, right? I think they who did this over there, right? So please be aware of this. And yeah, I think basically we are all right. We didn't do, oh, I'm sorry, I put this over here. Oh, I'm sorry. Yeah. And also, actually, we didn't really, I think this is okay. This one is okay over here. But actually, it could be written like this. Okay? A little more simplified one. And yes, that will be, and the last one is wrong, actually. It's just this plus 1, actually. The last one. This plus 1. Okay? So please be careful with that. And this will be your assignment. Thank you very much. See you next week. This one, this one. Perfect class.
If I was a teacher, oh my God.
Why do you say that?